Hi, Cal Polypomona. This is Daryl Diebold. I'm with IBM Security. I'm a global senior advisor, and I'm excited to be with you guys today just to share a little bit about what I see as the fundamental security dilemma. I'm sure you guys are coming from a lot of different backgrounds, but this topic should be a little interesting. We're not going to come at it purely from a technical angle. We're going to look at it from a historical perspective, and you're going to be listening to some of the things I'm saying that I'm not necessarily going to be displaying on the screen. So you want to pay attention to that as well. And hopefully this will be helpful for you guys, spark some interest and thoughts from a more asymmetrical perspective on what the problem is that we're really facing. So I'm going to dive right in to the presentation and start that. Here we go. So the fundamental cybersecurity dilemma and mission. So these are two names that really stick out to me when I think about where we are with regard to the adoption of technology in business, how we got here. Not really well known, not discussed. Two people you probably don't hear about. John T. Diebold, you want to look him up, actually started something called the Diebold Group. Post World War II, countries, companies, governments everywhere were leveraging him and his ideas to help figure out how they could leverage automation, primarily in manufacturing, but across business systems as well. And that's really interesting when you think about how far back these business models started way before, obviously, World War II. But the business models are fundamental to understanding what it is you're protecting. If you don't understand the nature of the business you're protecting, it's sort of odd that you could think that you could simply just run out and just start to do all these tasks and build and protect something you really don't understand what the function of it is. So why would I bring that up? In terms of what John did was to really bring automation into the business enterprise. Now, who's Claude Shannon? Claude Shannon was a graduate of small university in Michigan, and then MIT subsequently. He's considered to be the father of information theory. It lived from 1916 to 2001. And you could look him up. He's got some papers available. The reason Claude's so important is not just because he's considered the father of information theory, but because of how he thought about problems. He was unique in that um, he found it fundamentally important to identify clearly the problem that you're solving for. Otherwise, you're going to get caught up in all of these symptomatic solutions that don't necessarily deal with what it is you're trying to address. And I feel like we've moved further and further and further away from understanding fundamental problems and addressing them, and we seem to be continuously chasing after symptomatic issues. And so I bring those two guys up because I think you should go look into some of their background, where they fit into history, because I think they are sort of um, critical characters in terms of what they've delivered and brought into business models, governments, how we use and think about information and technology itself. This picture is going to seem odd, but why is this relevant? Organizational structure. Because in every group you're a part of, the university you're in, um, any of the clubs, organizations, the businesses you participate with, anything, and then subsequently after you graduate, what are you going to be doing? You're going to be joining an organization of some kind. And if you're going to be practicing cybersecurity, you need to understand the structure. Why is it structured this way if you're going to protect it? In the same way, if you're going to protect a physical asset, a house, you want to know where the doors and windows are if you're going to put cameras and locks in certain places. In an organization, you need to understand the structure of it. This is extremely relevant as you start to think about cybersecurity as a discipline. And most people overlook this. They jump straight into what's technical, right? What's cool, what's interesting. I only give this to you as a chart highlighting 3 levels of management hierarchy because organizations have structure that oftentimes can be of different kinds, right? There's functional design, divisional, team-based, flat, matrix, circular, network design. All of these different designs have an impact on how services are consumed, demand internally for technology services specifically, how they're driven up and supported and utilized. And in cybersecurity, we need to know that because what are we doing? We're actually protecting those services and the users, both internally and externally. As you think about protecting those, it's important to step back for a minute and go, okay, technology. How do we get here? And what fundamentally, how quickly has this happened in terms of our adoption of technology uh, as a whole, right? As a society, as a world. If you go back to the 1850s, electricity is discovered in 73, the telephone in 76, 1876, not 1976, the radio in 1897. So within a span of 50 years, you have electricity, the telephone, and radio. Then you look at the next 50 years and you just have television. And then after the television from 1950 to 2000, you have a pretty big jump from 1975, 83, 91 that drives what we see today, which was the PC, mobile phone, and especially the World Wide Web in 1991. And then subsequently the driverless car, which we have partially, but obviously they projected this wrong. They said by 2017, we'd all have driverless cars, and we don't. But the comment at the bottom, you are already part cyborg, is sort of a mantra of people who talk about the use of, for instance, the smartphone or smart devices, primarily the smartphone, because you're carrying around in your pocket or wherever it is on your person, a device that's more powerful than the first computers that consumed many rooms, right? And there's a useful book for you to go look at if you can speak German, because it hasn't been translated into English yet, by Manfred Spitzer, and it's called Die Smartphone Epidemic. It just means the smartphone epidemic. And he points and cites what the smartphone or the adoption and then the subsequent consumerization and use of smart devices has done to the human brain, or neuroelasticity, if you want to go look up that term, and how it's reshaped how we literally think and our sense organs. There's an interesting comment he makes in there about how it's changed nearsightedness in certain Asian countries because of the amount of use of those devices on a daily basis. Now, why is this all relevant to cybersecurity? Well, because the consumption of those technologies and subsequently this one is really what's been driving what it is we're trying to protect, which we'll get to later in this presentation. But the history of ERP, if you don't know what that is, it's enterprise resource planning. Now, why is this relevant? Because going back to the organizations that you're a part of, they all leverage enterprise resource planning systems that started in the 1960s to support, going back to John T. Diebold, this is where automation sort of found its hinge or hook into leveraging technology to drive automation across a lot of basic functions that were happening on manufacturing floors with the advent of material requirement planning systems like MAPIX, and then into the 70s with more advanced MRP systems, and then connecting those things to resource systems, which led to the 1990s. And that's really when you see ERP take off with companies like Oracle and SAP. And now every company and government in the world leverages ERP and subsequently some aspects of those technologies in their businesses. They're wholly dependent on these capabilities, the functions that are provided through each category of them. Some of those categories are here, like professional service automation, corporate performance management, customer relationships, CRM, e-commerce, which you all use on a daily basis, finance, human resource management, product lifecycle management, manufacturing supply chain, supplier relationship. These are just a handful of them, but they're some of the core systems that make up ERP or enterprise resource planning. And why is this important to cybersecurity? Because again, going back to if there's this much automation and the adoption of these technologies, it's to provide it to people making decisions and iteratively adding value to their businesses by performing whatever role they've been hired for and meeting those responsibilities by addressing the requirements on a daily basis that they're required to do leveraging these systems. This is just more of a push into understanding where things are going, as you'll see in these next two slides. But this is RPA, robotic process automation, and the hopes of what it's supposed to bring, which is low risk, non-invasive technology, reliability, right? That with more automation, you have more reliable services. right shoring, which is geographical independence without business case impact, just the idea that you can control the supply chain and how these services are delivered, scalable, productive. I won't go over all these, but you just get a look at it. But this is the holistic promise, supposedly, of automation and leveraging technology through RPA, for instance. Now, are we there? No. But is this where things are going? In some cases, yes, right? And I'll get to what, my constant focus on automation, why it's so significant here as we talk about cybersecurity. The automated workplace, if you think about RPA and where it's supposed to be driving us, is the idea that 45% of work activities are likely to be automated, according to PricewaterhouseCoopers in 2016, from some of their projected studies. And the idea that in 2020, we're in 2022 now, that process automation and AI will create 2.3 million jobs and eliminate 1.8 million. I don't know that we're there. Gartner said this in 2018. I don't believe we've created that many jobs and eliminated that many with process automation from the time of this study. But it's interesting when you look at this infographic. If you go back to 1439 and Gutenberg inventing the first press, little tidbit, I actually worked in the printing industry for a short window of time. And I'm familiar with setting up all of those machines and different printing processes. You fast forward to 2015 and Amazon creates the first virtual assistant, Alexa, well, the most prominently used one. And so this is a significant jump when you look at all of the automation, the advent and adoption of technology. And the biggest part really has happened from 1990 till now in terms of the amount of a technology adoption that's happened pervasively, and how this whole idea of the connected communities of people around the world all have access to the internet in some form or another, even in some of the most remote places now. They don't all have access, but it's significant, the number of people that are connected and the amount of information they're creating on a daily basis. I promise I'd talk about some of this as we talk about technology adoption and utilization in businesses. Edge computing architecture. This is where these IT services are going. So as you think about businesses and their adoption of automation, how they're doing that through leveraging technology, specifically in different categories. ERP is the one I wanted to focus on primarily because there's so many others, but they all really spin off of this idea that you can get a single pane of glass view into your business or organization or institution, so that you can then leverage what you're seeing in these core functions to then make quick decisions to capitalize on iterative value that can be created at those points. Now, what is edge computing purporting to do is to provide these services in a more nimble way across these companies and institutions and governments, by leveraging the cloud, right? And then this layer in the middle of nodes that are going to act to filter the data and move the most relevant data up. Again, this is all an idea and architecture, not necessarily realized by any one company. And then using the edge layer for real-time data processing and data filtration, all at these edge servers and these sensors. And think of that, the sensors as really being what we said earlier, mobile devices. As I was focusing in on the user, the most iterative point at which data is created is you, the user, a person, picking up the most commonly used piece of technology that you utilize all the time, your smart device, your phone. And then as you interact with it, the idea that you're becoming more cybernetic, and it is literally changing your brain. But then how do we secure every part of that service from you accessing it there, all the way subsequently through this whole idea as we move to edge computing architecture? It's going to exponentially expand the surface area and create this reverse funnel where that surface area is what cybersecurity professionals are going to be required to protect. And this will become more relevant as we get to the last diagram. The world population. As you think about users, since that's what you are and I am, from 1950 to 2050, the projected population is supposed to get to 9 billion. We're already at almost 8 billion. Well before the attended 2030 deadline or 2030 window that they said we would be in, we're already at about 8 billion people globally, and a lot of people connected to devices. So we're creating a significant amount of data, right? And this is an idea when you think about big data This is really what is being mined from your interactions with your device and all of our interactions. It is the new currency, and it has been since the 90s. This idea of utilizing iterative value so that we could profile individuals and their habits and activities, and then subsequently you could, through an omni-channel strategy or other means, start to get them to interact more with the technology they're utilizing. And so as you do that, what are you doing? You're creating significant amount of data at an iterative level. This is just a picture of some of the big data tools from 2016. And I also worked in massively parallel processing, big data, and some of the AI ML as well. So this is just literally a drop in the proverbial bucket of what's out there now, 6 years later. And I'll try to expedite some of this as we get through. This is really, when you think about every minute of the day in 2019, number of videos watched, posts of an Instagram, Netflix, users streaming almost 700,000 videos daily, Twitch, 1 million videos daily, or I'm sorry, every minute of the day. Searches on Google, over 4.5 million. Uber rides, Airbnb, Instagram, 55,000 photos every minute of the day. Tinder, users swiping 1.4 million times every minute of the day. Skype, users making 231,000 calls every minute of the day. YouTube, we went back to the Twitter, users sending 500,000 tweets every minute of the day. So all of this automation and interaction, from the moment that we started adopting technology, and then what you will look back and historically has been called the consumerization of IT, is driving this surface area of continuous iterative interactions, people and technology interacting with other people, right? Or companies leveraging technology to interact with their consumers or the recipients of their service, if they're a government. And then subsequently, they're even interacting with their suppliers, and some of those suppliers are technology companies. This all drives us to talk about, okay, what is this doing for us from a cybersecurity perspective? This massive attack surface is growing and will grow even further in the advent of edge computing. And it's created this cybersecurity skills crisis, right? And I would adjust this infographic and say, it's really not just a skills crisis, it's a crisis of focus. And it's not just in cybersecurity, it's, I won't say further up, it's in a different part of the business or the model, the institutional models. It's in a different category. And I'll get to that when I get to my last diagram here that's coming up. This is just a picture, an incomplete but adequate picture to give you an idea of when we say that there are too many tools out there. This just screams lack of focus. That's what this screams. When you look at web security, endpoint, application, data, mobile, messaging, everyone seems to be pitching something with no seeming picture. So can all of these people be focused on what's fundamentally wrong in terms of what our mission should be in cybersecurity? No. So that means there's a lot of symptomatic noise, not meaningless, because some of these things can be very useful, but they can't all be useful. That's impossible. So we have to figure out, okay, fundamentally, what should we be focusing on in cybersecurity, and how did we get here? And this is where this diagram comes in, and I'll close out with this. This diagram I came up with about a decade ago, maybe more than a decade ago, and there's some really messy back of the napkin kind of drawings. And the reason I drew this diagram was to try to summarize fundamentally what cybersecurity should be focused on as we think about how can we build a sustainable model between the Security Operations Center and incident response so that we can create a feedback loop, and then drive out noise and increase focus and fidelity so that we can protect these enterprises. So to just give you some idea of what we're dealing with here, On average, a large enterprise that could have as many, sorry, a large enterprise that could have as many as 26,000 employees may have 5 dedicated security analysts or 10. But when you do the ratio math on that, 10 people monitoring 26,000 people using all of those technologies in the IT service stack that are supporting the business and these core systems which make up all of ERP. I didn't want to inundate you with all of the diagrams because you've seen these before and others like it. So I'll walk you through this and give you my rationale for why I think that what has to happen is this focus on the SOC and CSIRT, Security Operations Center, and the incident response team. Because I think it's achievable, and I think we have the advantage by having fewer people. Our disadvantage is that the business or the institutions and governments don't understand that for 70 years they've been adopting technology, but they haven't adapted their view of their risk posture. And so what's happened is now they're upside down. They've holistically are dependent on technology for all of this automation on a daily basis, minute by minute, hour by hour, day by day. But they don't, and they didn't see this as a category of risk. That doesn't really make a lot of sense when I think about it, because wherever your greatest dependency is, it should be the thing where you're focused most holistically to protect that, because your greatest dependency is how you extract or drive value into the market or to your service, your constituents. What is every company and institution and government's greatest dependency? Technology. Every single one without exception. And so to the extent that they're dependent on technology, they need to protect not just the technology, but the iterative value that's created there. The data, as one example, and the users that are creating that data iteratively, and the services they interact with to do it. And so if you go to the top left-hand corner of this diagram, as I'm facing it and you're seeing it, infrastructure and operations, in 1984, the NSA came up with something called defense in depth as a layered approach or model to protect businesses from cybersecurity attacks, threat actors. Really fundamentally, cybersecurity is very simple to all of you who are watching this. Cybersecurity is two things. It's threats and vulnerabilities. And so if you look across this diagram, and I can send a copy of this, by the way, upon request, infrastructure and operations maybe had 26 to 34% vulnerabilities and threat targets, but it made up 80% of the IT security point solution spend in the early 2000s. And so that momentum, that buying behavior has continued, and it has only slightly slowed recently. Applications development, the services, it's the largest area of vulnerability because there's really been little to no static code testing of applications or dynamic or integrated testing in a wholehearted way. If you don't believe me, just look at the largest software providers in the world and how many security vulnerabilities they're patching on a weekly basis and emergency patches that are going out. And then the exploit actors and how the threat actors are identifying those vulnerabilities. Bottom right corner, identity access and governance. This should never have been in IT. This really should have been an HR function because it has to do with people using technology and giving them permission based on the roles and responsibilities they were hired for. But this somehow got adopted or relegated to the IT function. And now you have all of these attempts at trying to protect people using technology by authenticating their access, who they are, right? Enterprise single sign-on, two-factor authentication, multi-factor. The biggest fundamental problem here in identity access governance is really federation. Achieving real-time federation is almost an impossibility when you think about going back to organizational design, how complex some of these organizations are. They're matricized or circular, but they're not mostly flat and they're not small. And so this has been an ongoing problem. On the bottom left category, you'll see database security. This is really data security. And when we talked about the advent of big data and what's driving it, users, and then our subsequent consumerization or adoption of technology, how do we protect all that data? We can't encrypt everything, right? That's driving with the brakes on. We can monitor it all, but you see all of these categories are driving symptomatic security problems. They're real problems, but they're symptoms of a fundamental problem. Are we going to achieve this idea of comprehensive visibility? are businesses and institutions and governments going to invest in comprehensive visibility? Why? You can't stop what you can't see. And if you can't see it, you can't stop it. Not to be redundant or circular. But in the outermost circle, you'll see these big data terms, volume, variety, and velocity, talking about the kinds of data. And then the areas of IT functions are providing sensor or signal intelligence into this outer layer it's not really a layer that's meant to diagram data adoption. It's just meant to give you themes so that you can understand what it is we're trying to achieve operationally. And so we want to use automation and augmentation where we can, not everywhere, where it drives the most value. Trying to automate everything is foolishness, because we need human interaction to qualify and to push out what we identify as noise, because only people are going to really understand what's relevant to their business and what's not. So I'm going to wrap this up by talking about the innermost circle. The T to D is time to discovery. T to R is time to respond. This is really a running average that's still increasing, 200 plus days, almost a year before we can identify and remediate vulnerabilities across these businesses. Because we're operating at such a difficult ratio of cybersecurity analysts, or those of you performing those functions in your enterprises, against threat actors in this massive attack surface. So how are we going to get our arms around this attack surface? Well, it's really looking at, okay, simplifying how we think about these services. It's users accessing services that at some point live on and rely upon assets, right? And then what we should be doing is the SOC should be bringing in all of that signal data, Security Operations Center, then doing correlation. Correlation is not search. It is not collection. You can't hide and go seek your way to successful security program. It won't work. And so leveraging pure search technologies to do it would imply that you have enough know-how, understanding where your threats are and vulnerabilities, so you know what to look for as well and where to find it. We all know that's not true. So we need something that has a rules engine. Why a rules engine? Because that's what you need for correlation. You need something that you can apply controls to that can automatically do the detection for you. Does that mean you don't do search? No. What it means is you're going to refine that process so that you drive what? That's why there are these arrows. More focus and greater fidelity by pushing out noise and pulling in relevant signal. But that has to start somewhere, and it starts in that operations center. And then as you identify suspicious activity, moving to the right, you qualify it, and then the incident response team will work that and push it out and say, no, that's just noise. Hey, no, that's really good signal, and it's good fidelity. We know what that is. That's a threat. It's malicious. Remediate it, send that back to the SOC, and now the SOC knows what? They look for that vector, that where are these threat actors targeting us from a vulnerability standpoint. And this continuous feedback model, as you leverage technologies here, should drive out more and more noise, and you should see more and more fidelity and focus. So that's my hope for what we do from a security operations standpoint, and then we understand that fundamentally what the dilemma is we're facing. It is really that businesses don't understand how they've grown in dependency around technology adoption from an automation standpoint, and they've driven the attack surface area up. And so fundamentally, we in security, our mission has to be, how do we improve, reduce, if you want to use that word, but improve our time to discovery and response? And how do we create this feedback model within our operations and incident response teams so that we can continue to pursue better and better security posture for our institutions and governments. Appreciate your time. Thank you so much. And I hope you all have a great week and a great time at the Cal Poly Pomona event.